Hi there. So today I'm going to be focusing on the norm, the Euclidean norm, type 2 norm, but I'm going to be talking about the complex numbers. So I already made a video about the Euclidean norm and how to calculate it because of linear algebra when we first encountered it. But I didn't actually talk about complex numbers. So I think it's time to talk about them. So there are different types of norm, which I'm not gonna analyze right now. I'm just gonna I'm just gonna talk about the Euclidean norm. So what's the norm of a complex number? Well, what if I ask you this? Something like let's crack on and start with an example. So what's the norm of, let's say, 1 plus 2i? Well, the norm of a complex number would just be if I call 1 as a and 2i as bi, so this one will just be the square root of a plus bi times a minus bi, which basically means that is a squared plus b squared. So whenever you encounter a norm, a type 2 norm of a complex number, you've got to remember that it is basically just the first number squared plus the second number squared. You can just, ignore the imaginary part, just, the coefficient in front of the imaginary part. So, as I said, this will be, well, I'll just do this, will be 1 squared plus 2 squared, which will give us 1 plus 4, which is the square root of 5. So the norm, the type 2 norm of this complex number is basically square root of 5. Let's do another quick example, just, to make the idea sink in. Although it's fairly easy, I mean, it's pretty straightforward. But anyway, yeah, let's find the norm of 3 plus 4i. Well, if you recall, it's just this. So the norm of a plus bi would just be the square root of a squared plus b squared. Therefore, we will have the square root of 3 squared plus 4 squared. So the square root of 9 plus 16, so the square root of 25, which is 5. So yeah, that's pretty much it.